Okay, so from here you can find the M, and then you can put here you can find the M. Okay, and you can put this M here and here, and you can find the mu h. This is your answer. Okay. Okay, now let's start uh, studying about string and tension. Okay, so you can suppose that uh, imagine that picking up a light string. Okay, we have some string. Okay, and which we holding at one end of the string. For example, we have this string, and this is my hand. Okay, I am holding this string by hand. If you pull to the right with your right hand with a force T, and the left with your left hand with a force T, then the string become for example, uh, okay, how to explain you? Okay, uh, I can give you example like this. Okay, this is a something we can say that pulley. Okay, and here is your hand. This is your hand. Okay, you can say that right hand, and this is your left hand. Left hand. Okay, if I apply a force in this direction, okay, then this thing up, and there is a tension. Okay, you can force apply in this direction, then there is a tension in opposite direction. Okay, here you see that the force is applied in this direction, then the tension is in this direction. Okay, understand? So uh, in such a case we can say that there is a tension in the string. So we can say that when we apply a force on a string, then there is a tension in a string. Okay, so at any point in the string, the tension pull is equal to right or left. Okay, he said that at any point, for example, here you want to look what is the tension, it is equal to the force. Okay, if you want to look here, it is also equal to the force applied in this direction. Is about again, this is a one more example. Consider, you can consider this is a rope. Okay, and this rope is attached with the ceiling. This is ceiling. Okay, so we can this is a small box which we attach with this string, and this box have a weight. Weight is 105 newton. Okay, so suppose that this rope is uniform. Uniform means that the thickness of the rope is almost constant. Okay, so here thickness and here thickness is same. Okay, so now the question is, what is the tension in the rope? Okay, we want to know what is the tension in the rope. Our question is, what is the tension in the rope? Okay, and you need to find the tension at this point. You also need to find the tension at the middle point, and you can also need to find the tension in this point. Okay, so we have a three point. We can see that we have a tension here, we can also find a tension here, we can also find a tension here. Okay, so this is homework. Okay, you guys also need to do this homework.
Sir.
Okay, now again the example which I gave you before, that this is a box and this is a pulley, and someone apply a force in this direction, they apply a force in this direction. Okay, so the tension is in this direction. Okay, so when you look in this side, when this man apply a force in this direction, so this box here at this point, the force is also in this direction. Okay, and the tension is also go in up direction. Okay, so this is ideal pulley. Okay, ideal pulley mean that the I mean the string, when you push on this string in this direction, the pulley does not change the direction, it remain constant. Okay, it is fixed it at one end. Okay, now let's try to solve this example, and then we can try then we can understand what is happening. For example, attraction device employ three pulleys. Okay, so we have a three pulleys, one, two, and no, one, two, and three. Okay, so the middle pulley is attached to the sole of the foot. This is something some person have a foot have a broken or something, and they attach with this pulley, middle pulley. Okay, and a mass m supply the tension in this rope. So this there is a mass m, and this supply a tension in the this string. Find the value of mass m if the force exerted on the sole of the foot by the middle pulley is to be at 165 newton. Okay, so pulley basically they apply a force of 165 newton. Okay, so we need to find a mass m. We need to find this m mass. Okay, so okay, this is our middle pulley. Okay, and this pulley, and here we have angle 40 degree, here also 40 degree. Okay, so in this direction the tension is T. Okay, and here also we have a tension T. Okay, so this is a, so we need to resolve. So this component become T sine theta. Okay, theta is 40 degree, and this component is become uh, uh 40 degree. Yes, this is also T sine theta. Okay, there is a horizontal component. Horizontal component we can say that T cos theta, and this horizontal component we also call T cos theta. But vertical component you can see that T sine theta and T sine theta both are equal, so they cancel each other. Okay, so if you want to look the vertical fy, you can see that T sine theta minus T sine theta. So net vertical component force is 0. Okay, understand? So what about the horizontal component force? So horizontal component is T cos theta, and the other one is also T cos theta. So this is 2T cos theta. Okay, so 2T cos theta, and now you need to find a mass. Okay, so how to find a mass? Anyone tell us? Who can tell me that how to find a mass? Anyone tell? Do you guys know how to find? Hmm? We read before F equal to mg. Do you know how to find? Because homework is very important. If you don't do homework, then how you understand the future things? So try to, when I give you some homework, you can try at home. Okay, if you have some problem, you can send me message on WeChat. I can tell you how to do this.
Okay, sir.
Yeah, it is very important. I mean, otherwise, I mean, it is very difficult for you to understand. Okay, you can put this equal to mg, and then you can find a ms. Okay, you can put this equal to mg, and then you can find a mass. You can try this one. This is answer I write here. Okay, yeah, if you don't get this answer, you can let me know by WeChat. I can tell you the solution how to find this one.
Yes, sir.
Okay, now we can try to understand the spring and hook law. Okay, so this is my spring, for example, and this they have a mass m. So if I apply a force on spring, for example, in this direction, uh, for example, spring at maybe Let me try. We have a spring, for example. This is my spring, okay, and this is, for example, x equal to 0 position. Now I want to stretch this spring here. So this spring move some distance, for example, x distance. Okay, when you leave this spring, it come back. It come back, for example, here. Okay, so x distance he come back. Okay, so the force act on a spring is proportional to distance. Okay, force is proportional to x. So when proportionality we can remove, we have a F equal to kx, and k is a constant to proportionality, and it is called shifting constant. Okay, and you know that the force has a unit of Newton, and x is a unit of a meter, and k is a unit of newtons per meter. Okay, so unit of k is we have a F equal to kx. So we can say that F equal to F our x. F is Newton and distance is meter. So k has a unit Newton per meter. Okay. So if k has a large value, then the string is very stiff. Okay. If k has a small value, then string is very elastic. Okay. Okay. This is the same example. For example, we have a this spring, and here we can say that x equal to 0, and then I can stretch a spring a small distance, x distance. Okay, so now we can take a more x, 2x distance. Okay, so this is just show that you can say that here you have a zero force. Okay, here you can say that kappa x force. Here you can say that kappa 2x force. Okay, so in this direction force is positive. In this direction force is positive. In this direction force is positive. Similarly, the spring come back. Okay, when spring come back, this is a force applied by man. Okay, this is applied by human. Okay, this when you release the when you release the spring act a force opposite to the human. Okay, so in the opposite direction. So here the force is minus kx because the spring apply force in this direction. In this direction. Okay, so here similarly, if someone, for example, if a man, okay, man apply a force in this direction. Okay, the spring apply a force in this direction. Okay, you have a block and you can push this block in this direction, and the spring apply a force in this direction. Do anyone tell me why here this we have a minus kx? Who can tell me this thing? Adi, can you tell me why we have a negative force here? Who can tell me why we have a negative force here? Adi, are you there?
Yes,
Adi, why we have a negative force here?
right direction of because
Who is the Mishal? Mishal, are you there?
yes, sir.
So why we have a negative force here?
Because
Why?
we push the block towards the left.
No, I mean, okay, we push the block for the left, but what is the reason why we have a negative force? Here you can see that even we push the block toward the right, but we still have a negative force.
Opposite direction.
Anyone else who can tell me?
Opposite direction.
Yeah, because here, you apply force in this direction, okay, but the spring apply a force in opposite direction, so that is why negative. But here you can push the block in this direction, but you can see that from here to upward you have a positive distance, but from zero to backward you have a negative distance. So that is why here the force applied by this person is a negative force, but the spring apply in a positive force. Okay. Okay, now there is a hook law. Okay, this kind of physics can be explained by using hook law. So hook law say that if we stretch in the spring so that end of the spring is positive value of x, then the spring exert a force kx in the negative direction. Okay, for example, as I told you that this is a spring. Okay, and you can push the spring in positive direction. Okay, the hook law say that the spring apply a force in the negative direction, which is this force. Okay, and the other is if someone push the spring in the negative direction, then the force applied by the spring is in the positive direction. Okay, so uh, consider compressing the spring. If you compress the spring, okay, in the negative direction, in this case the force exerted by spring of magnitude is kx. Okay, and the point in the positive x direction, again we can say that the force in this case is this. Okay. Okay, this is same slide. Okay, this is one example, because you can think about that if someone have a nose and his nose has a broken hair. Okay, and doctor use such kind of devices to make their nose better. Okay, so we can read this statement and then we can solve this. Okay, uh, an increasing popular device for improving airflow through the nasal passage in the nasal strip, which consists of two flat polyester spring. Okay, this is a two flat polyester spring, and it is a band on over the nose. Measurement showed that the nasal strip exert a outward force of 0.22 Newton on the nose. Okay, he said that this basically this is your nose. Okay, and this maybe you can think about this strip. They push the force here and apply the force in this direction. Okay, and they can expand your nose little bit, about 3.6 meter. Okay, this is your normal nose. Okay, when you put this, they the spring exert a force in this direction, and this side they exert a force in this direction. Okay, and they can expand your nose 3.6 millimeter. Okay, treating the nose as an ideal spring, you can consider this as the ideal spring. Find the force constant that in the Newton per meter. Okay, so you can find very easily. You know that F equal to kx. Okay, and you have a I just find the Newton. You need to find k. So you have a force of 0.22 k, and x you have a 3.6 millimeter. So you need to convert millimeter into meter, and then you need to divide here so you can get a constant. Okay, how much force will be required to expand a nose? Now he said that uh, now you know this k. Okay, and you need to again find if you want to expand. Okay, If you want to expand a nose 4.1 millimeter, how much force you need? Okay, so you can again use F equal to K and X. Okay, so K you can find from here and you can use here. Okay, this K, which is basically 61. Okay, and now the X is 4.1 millimeter, so you can find the force. Okay, any question? Do you guys understand?
Yes, sir.
Okay, okay, now we have a 10 minutes break and then we can start again. Okay,
Okay, sir.
I want to know who is online. First I need to how many students are online, how many just online and they are not here. Okay, uh, Nadia is here. Okay, Veena is here.
Yes, sir.
Okay, Tanisha is here. Is the student here or not here? Okay, Haja is here. Mm-hmm. Okay, and who is this student? Nisa, right? Nisa is here.
Yes, Lausha.
Okay, Nabila
Yes, sir.
and Alvin.
Yes,
Alvin is
sir.
here. Okay,
Yes.
and who is this Agry?
Yes, sir.
So how to pronounce your name?
Agree, agree.
Agri. Okay,
Yes, agree.
okay, Agri. And this is uh, ALA. Who is this?
Yes, sir.
How to pronounce your name?
Alam, sir.
Alam, right?
Alam.
Okay, Alam. Okay. So do you guys have any question about previous lectures or if you not understand something? Have any question? I also mentioned before you don't shy, you just try to chat, okay? If
I
you
think
are
so.
shy, yeah, if you are shy like this, then how you become a doctor? Doctor need to chat a lot of things to the patient, okay? Even do not shy. I mean, even some student if have some problem in English speaking, so no problem. I mean, whatever what kind of speaking you can do, you can do. No problem. Do not need to shy.
Okay, sir. Okay, sir.
So how is the weather in your country? Is good nowadays? Summer start.
It's hot.
Hmm.
It's very hot, Lasha.
Okay. So weather. What is the temperature nowadays?
25.
25. So you guys are from Indonesia, right? Or Malaysia?
Indonesia.
Indonesia.
Indonesia, sir.
Indonesia. So all of your students are from Indonesia, right?
Yes, sir. Yes, sir.
Okay.
Sir.
So you joined this university which semester? This is your first semester or your second? This is your first semester here?
No, sir. It's our second year.
Oh, second year. Okay. So you guys never visit China, right?
Yes, sir.
Okay. I hope COVID will become better and you guys come to campus.
Yes, sir. We hope that so.
Okay. You can take rest and drink some water and we can start again after 5 minutes. Okay.
Okay.
Can we start again? Are you guys there?
Yes, sir.
Yes, sir.
Okay, let's start. Yeah.
Yes.
Okay, now we can do another example, and this is some basket of flower, and someone put a first. This is your string, okay, and then you can put a hook here and attach a basket here, okay. So this is some angle theta. So there is a tension T2, and here we have a tension T1. So we need to
Sir.
find T1 and T2. Is okay? Do you guys understand?
Sir, you haven't share screen.
Oh, it's not. Okay. Okay, now is okay.
Now it's okay.
Yes,
Okay,
sir.
okay. I can explain you again. So basically, this is a some string, okay, and then here we can put a hook and attach a basket of flower, okay. So this string here we have a tension T1, and here we have a tension 2. We need to find T1 and T2, okay. So you can see that, okay, this is a small angle theta, okay. So we can say that this is T2 cos theta, sorry, T1 cos theta. Okay, if I give it this name T2 and this is T1, so this is T2 cos theta, and the component here is T2 sin theta, okay. uh, you can see that T2 sin theta is equal to the upward component is equal to W, where this is your equation 1, and the horizontal, you have it T2 cos theta, which is equal to T1, because this T2 cos theta is equal to T1. This is your equation number 2, okay. So in the first equation you can find a T2, okay. You know that W equal to, we have an angle theta, this, and this W is equal to 6.2, okay. So we can find a T2. After finding T2 we can use T2 here and we can find a T1, okay. Understand? Okay, now we can do another example. For example, this is a bag, okay, and this bag have a weight of 1.84 kg, okay, and oh, oh, okay, actually there is some text behind this, but the picture come up. Okay, I will give you updated PDF after correcting this. So angle is, we have a theta is 3.5, okay. So we need to find a tension 3.5 degrees. We need to find a tension, okay. So again you need to solve, this is your homework, okay. This question is almost the same question which we had here, do here, okay. So you need to, first you need to do this. This is, if I solve this one, so this is T cos theta and this is T sin theta, okay. And if I do here, so again this is T sin theta, T cos theta, okay. So you can see that horizontal they cancel each other, okay. In horizontal they cancel, so vertically you can say that 2T sin theta, because T sin theta, T sin theta, and this is equal to W. So you can choose this value and find T, okay. This is your homework also. Okay, now we can consider a connecting object, okay. So for example, uh, I have a okay, consider accelerating object that are tied together, okay. These are two objects and they are tied together, and a force F pull the two boxes, and we have applied a force F here which can push these two forces, and these two boxes are connected by a string. Okay, and these two boxes are moving in the same direction. Okay, the box 1 has horizontal force acting on it. Okay, this is M1 and horizontal force acting on it. The tension T is the left direction. Okay, there is a string, so tension T is in left direction. Okay, and this I mean the box 2 tension is in this direction. Okay, so if we have a two object, they are connected by a string, then the first object have a force in this direction, then tension is in this direction, but the second object, the tension is also in this direction. Okay, so uh, this is same slide, I put it 2 times. Okay, now we can try to understand a one example and then try to understand this concept. For example, we have a block. This is the block M1, and they have a mass of 1.5 kg. Okay, and this is a block M2, and it's have a mass of M2 0.75 kg. So find it acceleration of the mass. So we need to find acceleration of the mass and also find this tension in the string. Okay, so let's try to understand first one, this one. Okay, so this is my M1. Okay, and you know that its weight is acting downward. W1 is downward, and the table act up force, normal force, and 1 1. Okay, and now try to understand. Okay, here you can find. Okay, you can write. Okay, so normal force equal to W1. Okay, so normal force, you know that MA, and W1 is, what is your W1? W1 have or not? Okay, no have. Mg. So mm cancel, and you have A equal to acceleration of the masses. For this block, we have only the downward force is gravity. Okay, but we need to find a horizontal. We need to find a horizontal. Okay, so now come to this block. So in this block, we try to understand in this block. So this is M2. Okay, so M2 block, you see that the tension is, this tension is upward direction. Okay, the tension is upward direction, and weight is a downward direction. Okay, so from here you can find a tension. Okay, and then using this tension you can find the acceleration. Okay, do you understand or not?
Yes, sir.
Understand, sir.
I mean, this T equal to, you can see that T equal to W2. Okay, so W2, you know that W2 is M2 and G. Okay, so M2, what is your M2? This is your M2. Okay, and you need to multiply by this, and you can find it in the one. But you, okay, there is some mistake I did. Okay, I can tell you. Basically, when you look downward, so you have a W2 and also you have a W1. So your tension is basically W1 plus W2. Okay, so in this case you can find a tension, and then you can find the acceleration, how they move. Okay, so for acceleration, you know that equation of motion, you can use equation of motions. Okay, so you can also try this one. If you don't try, you can let me know, I can give you solution. Okay, but I write here answer, you just look the answer. Okay, you try to match. If you don't get this answer, you just let me know, I can solve this and give you solution. Okay, now we want to try to understand circular motion. Okay. Uh, okay. You know that Newton's second law. Okay. In Newton's second law, we see that if no force act on an object, it will move along a constant speed. Okay, in a constant direction. For example, if a body want to move here, okay, so if there is a no force act on this body, they always continue to move in this direction. Okay, so if you want to change the speed of this body, okay, if you want to change the speed of this body, you need to apply a force. Okay, a force is required to change the speed of the or or direction or both. Okay, you can by applying force you can change the speed, by applying force you can change the direction, or you can change both speed and direction together. Okay, if you drive a car with a constant speed on a circular track, okay, for example, I have a this is a circular track. Okay, maybe I can make a road. Okay, this is circular track. Okay, and this is your car, and they want to move in this direction. Okay, so you can see that the car is moving in a constant speed. Okay, the speed is constant. Speed is constant, but you can see that direction is changing. Okay, direction is changing. Is changing. Okay, so a force must apply act on a car to cause this change in direction. So it means that there is a force act on a car who want to change its direction. Okay, and this force we call later I will tell you this force is called centripetal force. Okay, so for example, there is a some person who have a some string, and this is a small ball, and he want to just like rotate this ball, okay, around his head. Okay, so this is a small diagram where you can look at the ball which he want to rotate in head. Okay, for example, uh, we have a radius r, and this is the angle theta, and for any point, if you want to find a linear velocity, okay, if you want to find a linear velocity, you need to draw a tangent. Okay, tangent basically is a line who touch this curve at one point. Okay, from here, from here, or from here, any point. Okay, okay. The other important point is that on the other end of the string where it attached to the ball, the tension pull inward. Okay, so here the tension is basically pulling this ball inward. Okay, and the force the ball experience in the force is always directed toward the center of the circle. I mean, okay, if this is a string, the tension is acting in this direction, and this force is always toward the center of the uh, center of the string. Okay, some person is standing here, so they apply a force when they want to move around a circle. So this if there is a ball, it always act a force in the center. Okay, so due to this force, the okay, tension is acting in this direction and normal force is acting in this direction. Okay, so tension is in this direction, normal force is direction, so they both are balanced. Okay, so on a circular track, they move with a constant speed. Okay, they move with a constant speed. Okay, but this force changing the direction of the circle. Okay, this force changing the direction of the circle. So okay, so okay, the force changing the circular direction of of this ball is called I mean we can call it centripetal acceleration. Okay, so we can mathematically write in this direction. Okay, so here I can put a some question. How can a ball that move with a constant speed have a acceleration? Okay, this ball move in a constant speed, they have acceleration. Constant speed mean that because this ball has changing its direction. Okay, oh, this is the answer. Okay, Acceleration is produced whenever the speed or direction of the velocity changes. Okay, speed here is a constant. Okay, in our case, speed is a constant. Only direction changes. Okay, due to in a circular motion, the direction change continuously. So you can see that direction change continuously. So they have a acceleration. Okay, the resulting center directed acceleration is called centripetal acceleration. Okay, this acceleration is called centripetal acceleration. Okay, the direction of acceleration is always toward the center of the circle. Okay, the acceleration is always a center of the circle, and its magnitude is given by this. Okay, v square over r. This is its magnitude. Okay, now we try to summarize some more points. Uh, when an object moves in a circular path of radius r with a constant speed v, its centripetal acceleration has a magnitude given by this. Okay, the centripetal force must be applied to an object to give it circular motion. Okay, a centripetal force must be applied to an object is give to circular motion. Okay, so for an object of mass m, for example, we have a mass m, and this mass is rotating along the circle. Okay, so the magnitude of centripetal force we can write by Newton's second law. You know that Newton's second law, ma. Okay, but now the acceleration is centripetal acceleration. So by using this, we can write the centripetal acceleration. Okay, just give me 1 minute. Someone calling me. Hello. Just give me 1 minute. Okay, sorry for that. Okay, let's start again. Okay, do you understand? Because we have, from Newton's second law, we can write force equal to ma. Okay, now we have a acceleration is centripetal acceleration. So centripetal acceleration is defined by this. So when I use this here, we have this formula. This is a formula of the centripetal force. Okay, this is our centripetal force. Centripetal force. Okay, and this force is always direction toward the center of the circle. Okay, the force direction is always in this direction, center of the circle. Okay, okay, the centripetal force is basically produced in number of ways. Okay, there are many ways you can use to produce centripetal force. Okay, for example, centripetal force might be a tension in a string. Okay, as an example of with the ball. For example, this is a ball, and here if I want to make it rotate like this, so tension is like this. So in this case, centripetal force and tensions are equal. Okay, the other example is might be due to the friction between the tires and the road in when the car is turn a corner. Okay, for example, the other example is, for example, this is a tongue. Okay, this is your car. This is maybe I can say that this is road. Okay, and some car they want to move turn. Okay, this is our car, and they want to turn. When they turn, there is a tension. Okay, in this case, this is a center of the, you can say that, the road, not road, maybe you can say that this is the center of the tongue. Okay, so in this case, the friction between this, because the friction force is in this direction, Fk. Okay, this friction force is basically centripetal force. Okay, or could be the force of gravity that causes satellites, or the the motion to the orbit the circle. For example, this is our Earth. Okay, this is our Earth, and maybe someone have a satellites. Okay, this is satellites, different satellites. So in this case, the gravity force, because the gravity attracts these satellites. Okay, in this case, the gravity, okay, the gravity attract these satellites. So in this case, the gravity basically act as a centripetal force. Okay, so important point is that centripetal force must be present to cause a circular motion. Okay, this is the main point. For if you want a circular motion, you must need a centripetal force. Okay, now we can try to understand another example. For example, this is a some car. Okay, and this car want to turn the road. Okay, and the static friction between the road and the car is, coefficient of static friction is this one. Okay, the radius of this circular track is 45 meter. Okay, so what is the greatest speed the car can be in the corner without skidding? Okay, so uh, okay, here you can see that normal is equal to weight. Okay, and Fs is equal to centripetal force. Okay, and centripetal force, you know that the formula of centripetal force, mv square over r. So you can put mv square over r. Okay, and Fs, you know that what is the formula of static friction? I teach you before. Where is static friction? Static friction. Where is the static friction? Okay, this is the static friction formula. Okay, so you can use here static friction. Okay, here you can use mu s into n. Okay, so n equal to w. So you use the same mu s into w m v square over r. So just multiply this and divide it by m, and then use this value to find a v. Okay, which is 19 meter per second. Okay, could you guys understand this problem or not? Do you understand or not?
Yes, sir.
Okay. Okay, now we can try to understand another topic, which is basically linear momentum. Okay, linear momentum is basically defined as the product of mass and velocity. Okay, so if you multiply mass multiply by velocity, you can get a linear momentum. Okay, so uh, linear momentum is a vector quantity. Okay, v is a vector quantity. Both have magnitude and direction, so momentum is also a vector quantity. So momentum have a same direction. Momentum have same direction as velocity. Okay, so magnitude of linear momentum is defined by this. Okay, so for example, this is some example questions. For example, a 72.3 kg jogger run with a speed of 3.3. Okay, you have a mass 72.3 kg. Okay, so you have a velocity 3. 13 meter per second, okay, in the x direction, like in this direction. Okay, what is the jogger momentum? So you need to find momentum. So you can say that P equal to mv. Use this m, 72.3 multiplied by v, 3.13. Okay, so you can get the answer. Okay, similarly you can solve, this is homework. Okay, you can solve this one and this one. Okay, and then give me same. Okay, for example, we know that the momentum is a vector quantity. Okay, and if there are so many bodies, for example, this one have mass m1, and this have m2, and this have m3, and so many. Okay, like this is mn. So this particle have a momentum p1, this have p2, and this is p3, and this is a pn. So if I want to add total momentum, so we can add vectorly. Okay, we can add this by vector method. Vector method. So vector method, you know that if we have a p1, okay, this is a p2, and this is, for example, p3. So this is basically, so this is p total. Okay, this is a vector method to add the all the momentums. Okay, this is also one example. You can do homework. Okay, now we can take a 10 minutes break and then come back. Okay, okay, 10 minutes break and we can come back. Hello, can you hear me?
Hello.
Hello.
Yes, Lausha.
Okay, I
Yes,
I
sir.
I, I write the solution of this example here, so you can follow this example and you can do homework. Okay.
Okay.
Okay. Now we can try to understand momentum and Newton's second law. Okay. For example, you can consider a change in momentum. For example, we have a mass m1 and it's have a momentum here p1, and this position again the mass is same but momentum is changing. Okay. So if we want to write a change in momentum, so we have final momentum minus initial momentum. So momentum, you know that mvf minus mvi. So you can take common and you can write final velocity minus initial velocity. So in this thing we can also write by delta v. Okay. So from Newton's second law, we know that uh, uh, okay uh, from Newton's second law we have this sum of force equal to ma. Okay. And you can write from this equation delta p equal to m delta v, and you know that p is equal basically you can write okay, here we can use different definition. You know that acceleration is basically change in velocity divided by time. Okay. And we can use this definition here. So we have a sum of force equal to m into change in velocity divided by time. Okay. So if this is equation number one and this is your equation number two. Okay. So if I use delta v value and put here, so we can get this kind of relation. Okay. So change in momentum basically force multiplied by time. Okay, this is another definition of momentum. Okay. So one definition is before we start, see that momentum is basically mass multiplied by change in velocity, and this is another definition which is sum of force multiplied by in small time. Okay. So from here you can write delta p by delta t. Okay. So Newton's second law in terms of momentum is sum of force equal to change in momentum divided by time. So you can write like this: Newton's second law. So what is the definition? Sum of force is equal to rate of change of momentum. Change of rate of change of momentum. Okay. So sum of force equal to rate of a change of momentum. Okay. Now we study another important topic which is impulse. Okay. So impulse is basically force, average force acting on an object and the amount of time delta t. Okay. So this is a definition of a impulse. So impulse is basically product of average force acting on an object and amount of time delta t. Okay. So we know that force is basically a change of momentum divided by delta t. Okay. So if I multiply this here, so we can say that change in momentum basically force total multiplied by delta t. So there is a theorem which is called momentum impulse theorem. Okay. So momentum impulse theorem is basically the impulse is equal to change in momentum. Okay. The impulse is equal to change in momentum, because you know that this is force total divided by delta t, and we see from this definition the force, average force in delta t is basically impulse. So we can say that here impulse is equal to change in momentum. This is momentum impulse theorem. Okay, now we can study the conservation of linear momentum. Okay, so what is the conservation of linear momentum? The total momentum, initial momentum is equal to total final momentum. Okay, so if a net force acting on a object is zero, For example, this is my object, and if I force act along this direction and apply a force in this direction, okay. So, and linear law of conservation of linear momentum say total momentum at initial is equal to total momentum at final, okay. uh, the other thing is, in some cases the force is zero in one direction and non-zero in another direction. For example, an object in a free falling has a net no force in the x direction. For example, this object is falling down, so we can say that on x direction there is a no force, on y direction they have a force, okay. As a result, the object x component of momentum remain constant. So if I want to find the x component of momentum, it is a constant, okay. But the y component of the momentum changes with time, because this object is falling down. So y component is always changing, but x component is not changing, okay. Okay, we can study up to here, okay. So next class we can learn more. Do you guys have any question?
No, sir.
No, sir.
Okay, you can
No,
study
sir.
this thing and do all the homework, and send homework to Adi, okay, and then Adi can send me all the homework together. Homework is important because if you do homework you can get a marks, and also it is important for your exam, because I make a exam only in my PPT. What I write in my PPT, I can give exam within this PPT, okay. So you can try to understand and try to follow me, so you can get a good marks in exam. Okay, if you have no other question, then see you next class.
Okay,
Sir,
thank you, sir.
Yes.
may
Yes, you
I
can.
know when is the deadline of today's homework?
You can spend 1 week. I mean, for example, today I give homework, and next Monday you can submit to the homework. If I give Wednesday homework, then next Wednesday you can give homework. Give me back.
Okay, sir. Thank
Okay.
you.
Okay. Thanks. Bye. See you guys next class. Okay. Bye.
See you.
See you, sir. Thank you.
Thank you so much for today's class.